A quick little blurb about me. I grew up consulting. I actually had a little bit of a late start in life software development, fell in love with it. Have been doing quite a bit in the systems architecture kind of high level design world for a while, and have found a love for not only designing systems but also talking about design systems, because there's 8,000 ways to design a system. 100 ways of those you're going to be all right, and there's probably 900 of them that you're not going to be so great. And so with this talk in particular, please do pipe up if you see something that you want to ask questions and clarifications. Just because I'm really good at 900, that's funny. And because this is going to be a really boring talk if it's just me talking all the time, right? I think that's true in general with talks. But please do pipe up. There's going to be some code snapshots, but I'm not going to do any live coding. I feel like trying to type in front of people just is a bad time. So to dive into it, if there's pieces that you don't understand, or like there's wiring that's not being shown, you want to more of an understanding of that, please don't be afraid to interrupt me or to throw something in the chat if you've got a question. With that, I will start sharing my screen. Okay, how good. I'm normally a Teams person, so does this put it in presenter mode for you guys?
Yep, we see presenter mode at this point.
Great, that is awesome. All right, so we are going to be talking about Command Query Responsibility Segregation and Domain-Driven Design. That is a mouthful all by itself. But first, a little bit about me. I already gave a little bit of a bio. As Eric mentioned, I'm VP Consulting at Improving, Christian developer, improver, and lifelong learner. I don't think you can really be in the development world without some type of consistent learning through life. So it's become kind of a passion all by itself of mine. I am somebody who loves to connect with people, especially in the development world. I love to get an understanding of people's different perspectives, their expertise, their experience. I think there's so much gold in that and in the people that you come to contact with. So at any point you want to connect with me, I love continuing the conversation. So please do at any point in time. So to get started, this talk was birthed out of this kind of a basic alphabet soup of the world. And most of the time, you'll sit into a conversation, be talking to a group of developers, maybe your team, and you kind of go through all the alphabet soup of patterns and approaches and all of that. And you get this look on people's face that, to me, this is what plays in my head. They're just going, help. Like I get it. I've read all about these things. I've understood them in silos. I've maybe even practiced them on my own, or I've implemented them in different systems. How do these play together? How is this all supposed to look at the end of the day? And so this talk is specifically about the combination of those two patterns and how they play very nicely together to a system that can make something super clean and easy to test, hard to break, separation of concerns, all of those beautiful little phrases that you like to hear thrown around when you're working in software. So to do that, we need a very quick understanding of domain-driven design. I'm not going to go very deep into this, but just so you understand kind of a baseline of where I'm coming from, we're going to use an example throughout this entire time of a ticketing system. I think that's something that we're all relatively familiar. We want to go to a show, you have to buy a ticket, right? You want to go to the rodeo, you have to buy a ticket. The example I used here is Hamilton. I actually really want to go to this. That's where this entire idea came from. But the domain-driven design, the basic concept at a super high level is separating the concerns based on business domain at the aggregate root. Now, what that aggregate root can change if you're building very similar systems depending on the primary purpose of the system, right? So for example, for a ticketing system, your aggregate root could be an event, right? It could be Hamilton is your aggregate root, and all the tickets and the pricing and the management could be associated with that. Or you could have an aggregate root of a ticket where you purchase a ticket, you sell a ticket. It's all about the transaction around a ticket itself. And so in this example, we're going to use the very, very simple example of purchasing a ticket using ticket as the aggregate root in our particular example. Does that make sense to everybody so far?
Makes sense to me.
Cool. Again, if you get into it later and you're like, I missed something, please do stop me. But that is as far as I'm going to go in explaining what domain-driven design is. There's lots of really good documentation out there and blogs if you just Google that if you want to go deeper into that, or hit me up and love to talk. So we're going to spend most of the time talking about CQRS, and then we're going to get into the domain-driven design aspect of that. So we're going to start on the CQRS. We're going to start with talking about commands. We're going to break down the layers of the command side, and we're going to talk about queries. The nice thing about CQRS being Command Query Responsibility Segregation, that segregation really does split those into two completely different workflows. And so I'm going to talk about them completely differently, so you can assume that even if something is named similarly when I'm talking about a command, when I'm talking about a query, they're probably still in two very different places in your code base. Maybe different instances or implementations of that, except for the domain, go figure. So at a very high level, this is the basic structure for CQRS using domain-driven design. There's a whole bunch of stuff happening, and we're going to go through this one by one. But at a very high level, you have an action. That action is going to be the verb that is happening on your domain. In the case of purchasing a ticket, the purchase is the verb. So the purchase request is going to be the action, generally the thing coming from the UI in most cases. Gets received by something, routed, something handles it, impacts the domain, and then to the database, right? So let's talk about that on a step-by-step level. So get the action, you get an action receiver. So what is the responsibility of an action receiver? Generally, this looks like a controller or similar, especially if you're in an API-based system. It's going to be the API receiver. And its entire responsibility is make sure the input is valid, that, you would like, so for example, if I need the ticket ID is there. Ensure that the user has permissions to execute the action is all. That does not mean that the user has the permission to execute it on that ticket, just that that endpoint is available for that user. And it's simply at that point needs to create and figure out what event is happening and give that to the event router. So from an implementation perspective, what that looks like is something like this. So I'm pointing to the authorized steps because that is the level of authorization that we're talking about at this level. It's a very simple controller that says, hey, this is a purchase ticket. I'm getting a purchase request. Right here on inside of the HTTP post, you have a purchase request validation that is making sure that everything is in there that needs to be in there. And then it simply says, hey, this is the event, which is a ticket purchase event. Event router, handle it. And that is all it cares about in this world. Period. You are done. Questions about that?
I'm sure you'll go into it, but I would ask, what is the event router? Is it a library? Is it a custom thing? Yeah.
It is a custom thing. I believe that there will be a day that it comes out of a NuGet package of some kind. But that is exactly what is next. The router is something that is its entire responsibility is exactly what it sounds like. It is supposed to take that type of event, find the handler, and route to it. Now, depending on your system architecture and what you built it on, there's going to be lots of different ways that this can be implemented. But if you're using like an IOC container, you can actually go say, okay, I'm going to add this method signature to my IOC so that the event router can go pull that back out of the IOC once it's requested and then get that to be called. The nice thing about that is at times you can set up multiple handlers for the same event, and you can create kind of a distributed system of sorts. My general suggestion, if you're going something that far, you should probably be implementing something like a service bus or something of that sort. Service bus is an example of this type of infrastructure where we're pulling in an event, creating what type of event is, and sending it out into the world. Same concept there. So you can be doing something in IOC container, you can be doing something with service bus, RabbitMQ, whatever you decide to be using for the event handling there. And that really depends on how complex your system is, right? Something like Service Bus is going to be really good for event retries and transaction handling and error handling and all of those things. But in most simple systems, like your simple CRUD system, an IOC container handler is generally plenty. So what that looks like is significantly simpler than I think is initially assumed. So in this instance, we have this service resolver that is resolving handler for type. In this example, underneath the covers, that is using the IOC container. We're simply of type C, go figure out where that is in my world, and then go tell it to handle the input that I have been given. That answer your question, Eric?
It does. And Amir has a question. He asked, why doesn't the event validate the message it's sending as opposed to the validation being in the controller?
So the controller is validating the input request, right? So it's responsible for making sure that the HTTP request has everything that we expected it to give. And that is really the responsibility of the controller. In terms of, say, for example, the ticket ID that was given is an invalid ticket ID, that is a type of validation that would go all the way down to the event. So there's a little bit of a separation based on the data and what you need to validate it versus are you validating the request itself. Answer the question? Think so?
He thumbs up.
Cool. Thank you for watching the chat. I actually can't see it right now. Okay, so once that event is routed, you end up with these event handlers. Now, I generally recommend that you go ahead and have a handler per class set up in your code. That does mean that for large systems, you will have a huge swath of event handlers. But the nice thing about that is when you're going into a brand new system and it's set up this way, if you pop open those handlers and if they're categorized well, like by purchase, sale, purchase, transfer, purchase, whatever you might be in the ticket system, you can see all of the different features that system has, or what types of events can happen on that system pretty easily, and lets you ramp up on a system very well. So they're very much supposed to be a single unit of work, single purpose event handlers. They are responsible for knowing how to query the domain, how to pull it up, how to make sure it has all the information it needs, ensures this is where that other level of validation happens for the permissions. So it ensures that the user is allowed to perform the action on that set of data. It's like, cool, you are allowed to purchase tickets. Are you allowed to purchase this ticket? Is that ticket ID that you gave me a valid one? Those types of validations would go at this level, and then it'll call the action on that given domain. So what that would look like, and this is a very simple version of it. So you have some type of a domain repository. You have this ticket purchase event being as part of a handle. So you see that the actual class is a handler of type by event handle purchase ticket event, which that is what you're going to register your IOC container to look for, and to hydrate any type with that signature on it. The handle comes in and it immediately looks at the query, at the ticket to find it. It also needs to pull in the user to get more user information and then just the user ID to perform the action or any other data necessary for the action to happen on the domain, and then call purchase on that domain, passing in any necessary data. Now, the interesting thing here, which is often where I think CQRS takes a little bit of a left-hand turn, or there are two pieces to it. First is a lot of times there's like an event that happens, and then if this certain use case happens, then a secondary event needs to be triggered, or 3 other events need to be triggered, et cetera, et cetera. The nice thing about this system is that the domain can actually then register more events and can return a one or a list of other events that need to be handled. And so this handle event can then reroute the response of the domain actions that are more events back to the event handler. The only time that that's going to go awry is if you end up with more than 256 events deep, and if you're going that deep, you should probably consider distributed system using service bus or something of the sort anyways. And the other way that this goes awry is I think because of the way that we grew up in software where interacting with the database has always been a very manual transaction for a very long time. I think there have been more and more libraries out there that help us kind of disconnect that. But the behavior behind, no, I need to make sure that this thing that I'm changing is getting saved into the database. So oftentimes every single action that happens, all right, cool, I updated the domain, but that domain update needs to somehow transfer into a SQL query that updates the database. I need to make sure that that happens successfully. That's oftentimes another concern. Now, that is why I did not put a database layer on that bottom. And so we're going to talk about that in a minute, but I want to put a pin in that and call that out specifically here, because what you see on the screen is intended to be the entirety of what the handler should look like. Now, obviously, there's going to be some more complex handlers than this, querying more complex data, but ultimately, it should be orchestration. It should be get all the data that you need, do the types of validations that you need to do to make sure this we're allowed to do this, call action on domain, done, except for potentially call more events. But you don't actually know what those events are. The domain told you. That makes sense so far? All right. Can I get a feel for like who here is like, this is something I've heard before, I've done this 1,000 times, versus, okay, yeah, I kind of understand what you're talking about, but haven't done this before.
Anyone feel free to unmute yourself if you want to, or you can put something in the chat. I would say that I've never myself worked in a CQRS system before. I've seen presentations on it and whatnot, but I've never myself been in one of those situations. We've got heard about it, but never worked with it, and another. So I think you're dealing with some CQRS noobs like myself.
Okay, cool. So I wanted to make sure I wasn't boring the crap out of you guys. And if I'm also going too fast, please let me know. Okay, so again, we're querying, we're setting it to the domain does its thing, and we'll continue to see how the domain does that thing, right? So now we're into the domain. Now, back to the concept of domain-driven design, the domain is responsible for handling itself, right? So the domain, you say purchase on it, purchase could mean a lot of things. It could mean that the tickets next to it get split up because suddenly there's only 3 tickets there, or there's like 5 and they want to split up into a 3 and a 2 and they want special logic of how they do ticket sales. They could say, oh no, we're just going to set the owner of the ticket and we're done, and we're letting the entire invoicing process happen from another system entirely. So that would be an example of another event that needs to happen after a purchase to say, all right, ticket purchase says, yep, I purchased it. Now please go kick off, invoice them for this ticket request or event, please. And so in this example, I did the simplest possible version of this, right? Where a ticket has an owner that is a user, and specifically pointing out here that this follows the rule of domain data should never be editable outside of the domain. And I do mean never. And so there's an internal set, but you can read the data. The purchase, that's the user, and then does any of the other things that could happen here, including identifying other events, returning them, whatever that might be here. Then finally you get to data access. And in my opinion, this is where one of the bigger kind of mental cognitive dissonances happens, because there are several rules that float around data access, entities, how database representation exists in code or doesn't, all of that. And there's quite a bit of back and forth that I've heard in the market. But ultimately what this approach means is that there is no distinction in the code between an entity and a domain model. They are one and the same. There is no auto mapping magic that you have to do back and forth every single time that you actually want to make a change to the database, because ultimately the times that the domain is changing, because it's entirely locked down from changes in the outside world, if it's changing, it should be saved, period. Right? Um, and so what happens there is at the end of a transaction loop, so for example, in any framework, you set off a transaction, there's changes that happen to a domain object that is hooked up to the domain context in Entity Framework. You make changes on it, and the end of the thread auto commits the transaction. So any changes that happen to happen inside of the domain are auto saved to the database just by ending the transaction, right? Now there's transaction scoping and all of that, but that can be handled by the IOC container very well. So in this particular example, the data access, everything that maps what that ticket object means, what an owner means, how that foreign key is, what the columns are, all of that lives only in the configuration of the database context, right? Now, the really cool thing about this is you can do multi-level class inheritance with multiple tables that represents, and you can even combine two different database tables into a single domain context or domain object through this mapping, and you can get really creative with it, because ultimately this breaks that concept that the database structure and the relational database or non-relational, whatever you're doing back there, has to have anything to do with what your domain and code looks like. Now, doing this well means that you can build your system without ever even thinking about your database for almost the entirety of your project, right? You're just like, cool, I need this here, I need that there, I need this over here. Awesome, awesome, awesome. I've got a ticket owner. Okay, now I need a ticket price, and now I need this other thing. And then an owner needs a location and, an ability to invoice them, and this needs that. And you end up with this object structure. And then you get to the end of it, you go, all right, Entity Framework, what are they? I'm gonna go hook up all of these objects to be saved into the database. And then Entity Framework would make a lot of decisions for you. It'll be like, okay, cool. By default, I'm gonna assume that your object name is gonna be the same as your table name. I'm gonna assume your schema is DBO unless you change it like you see here on the screen of toTable with the schema name. I'm gonna assume that your property names match your names in the table, in the database. I'm gonna assume a whole bunch of this stuff. And a lot of those assumptions make developing code really, really easy. But it also means that it makes it a little bit more fragile for changes going down the road. So if you're going with this approach where you are pushing all of the concept and the thought process of what the translation is from the domain to the database down to this layer, that you be more verbose than you think you need to be. So for example, I added a foreign key of an owner or a user that is called an owner to this. Now, I would go as far as adding, what you can do in the syntax, with foreign key and give it the string name that the column name should be. That way, if down the road I don't like the name owner and I change it, it doesn't create a new database migration that potentially breaks things, or you have to finagle with existing data and all of that stuff. That remains pretty solid regardless of what I do in my domain. Now, obviously, larger changes in my domain that need database scripts will still happen and you can make those, but it makes it a little bit more of an intentional change and harder for little changes in the domain to mean suddenly your database is like, I don't recognize that column because you fixed the spelling of a column name. Those types of things. You with me so far? I have an example of this that I find interesting that I'm actually working on a system right now, where we have a concept of courses and we have a concept of events, which both have multiple dates they can be apply on for a single event, and registration and attendance per date occurrence, if that makes sense. So say, for example, you have a charity event that's 2 days long, and you want to put out there a registration for the charity event, and you have attendance on both of those days that you want to track. Similarly, in the same system, you have an actual like education course, and you have 2 sessions of that education course, session 1 being the basic, session 2 being like the 102 level or whatever that might be. Both of those have very similar concepts in the basis of registration, attendance, and those types of things, right? Now, what is cool about it is I can create a entity object that is kind of a base event type and a session that handles registration, attendance, and all of that. And I can inherit that in a event type and a course type of an event, and set all of that up in entity framework so that the tables all make sense with the correct foreign keys and one-to-one relationships or one-to-many relationships that I want. And at the end of the day, my object structure looks like all I did was build code without a database on it. Is that, you guys following that? Thank you guys who are nodding. You're helping me out a lot. I know my eyes are kind of off to the side. That's where the people are.
Now, does it ever backfire in your experience to wait until the very end before you do any database mapping, or is it just all actually work out?
Sometimes. So if you once you're extremely familiar with the types of things entity framework wants you to do, it becomes pretty easy. But until then, I would definitely recommend iterative approaches to entity framework, because I believe one of the biggest pain points of entity framework is it's sometimes very, very bad at telling you where the problem is. And so if you are like, hey, I've been doing entity framework for 6 years, I can basically tell you how it's thinking, feel free to leave it to the end. If you're a little bit more shy, I would do it probably maybe 2 table relationships at a time at most. And so when you're setting up the initial system is one thing, right? And then iterative development, I would definitely recommend each incremental database change and entity framework change associated to it. So now there's interesting kind of like things you have to be aware of, things you have to know how to set up in order to get this all to work right, which I believe are the makers or breakers. People get into trying to do CQRS, they get into trying to do domain-driven design, and they're like, this doesn't work in any framework. And I hear this all the time. And oftentimes it does work, but you have to kind of know how they think. So for example, if you have a parent-child relationship that if you remove the child from the parent, it should delete the child. That can be set up in entity framework to work so that you don't actually have to call like dbcontext.remove on that actual child object. Because if you think about it from a domain-driven design perspective, if I have a ticket and a ticket has 3 seats and I transfer one of those seats to somebody else and I want to remove that child from my parent, generally, if you were to just go, okay, ticket.remove seat, the default behavior of any framework is to remove the foreign key relationship, not remove and delete the child, unless you turn on cascade delete from the parent to the child relationship on this mapping, right? Which means that you have to pay a lot of attention to which direction are my foreign keys going, which one's cascading, which one's not. How do I make sure that I'm not having more than one parent cascade delete, because entity framework really doesn't like that. So for example, you have 2 parents that have foreign keys to the same child and they both say cascade, it'll be like, yeah, I don't know how to do that. It'll just throw up at you. I do recommend, again, a little of the iterative approaches, a lot of kind of unit testing around it to figure out what does entity framework do with this? What does it do with that? How does it handle this? But a lot of the complexity comes from really complex object structures that are more rare than people like to believe. All right. So we have this mapping. We have now been able to get to a point that the domain has no idea what your database is. Now, again, another beautiful thing about this is if you wanted to trade out SQL for Mongo, cool. Set up your mappings appropriately, trade it out. Your domain doesn't care at all. And that's the beauty of that system. And then you can also insert caching mechanism and those types of things if you're having issues with like performance to your database or whatever that might be. And you get to put in lots of different abstraction layers in that. A couple other things that this approach gives you is, especially at this level, the ability to implement stuff like feature toggling using your IOC container is absolutely gold. And is extremely easy to do at this level instead of like, okay, I need to like somehow carve this like random path of code through my base and like figure out how to turn a feature toggle on with that. It allows you to take this one unit of work, it's either on or off, or it is this version or that version for different situations. And so that is really the command side of it. And I went through that pretty quickly. Is there anything you guys want me to dive deeper into of how that's supposed to work underneath the covers? Oh, all right, let's talk about.
I do have one question.
Yes.
So I noticed, like on the event handler, for example, there's no return types. And so if you start an action and you want to know how that goes, right? You want to be able to tie this in and go, oh, I want to know when this command completes. How would you do that in this kind of scenario? It's probably something you're going to cover anyway.
So having the command complete is one thing. Having the command respond with something is a different story, right? Because nothing about the event handler or this path means you don't know when it's done, right? Because back up to this level, even though I'm going through a routing event, I could still say this is an async event, wait for it to be done. Once it's done, thank you very much. I could also highly recommend effective exception management system, which is essentially an event-based system, right? Throw this type of event, throw that type of event. And that way at this level, you're just handling different event types that are thrown and doing different type of handles with that, right? And letting you figure out what you want to do about those different situations. But to your point, one of the things that I think is extremely common in software development and on events where you want information back is going to be inserts, right? Create a new ticket. I want to know what my new ticket ID was, right? Now, that, in my opinion, is an anti-pattern because I think we've gotten so used to relying on SQL to generate IDs for us that we've forgotten that we don't have to, right? GUIDs are a great thing. And in fact, I know, in fact, I'm gonna make myself feel a little out of date right now, but for a while, I know the recommendation was each database table should have 2 IDs, right? You should have the ID that your system uses, which should be a GUID that is generated all the way at the creation of the event on the request, and an ID that the database can easily index. Now, I think in the later versions of SQL Server in the last couple of years, they've gotten really, really good at indexing GUIDs. And so the secondary ID isn't as necessary because there was one point in a time that effective indexing was really only done on integers. It's less of the case now, so you could probably just do it with a GUID. But what that means is all the information that you would need on response, you generally don't have to wait on it because we're separating those concerns that yes, a creation of something or an update on something, if you need it refresh, should result in a completely separate request to requery it based on the response of this one. This one says success done. This one says, okay, cool, go query, or I don't need you to query, I'm good, thanks. And what that does is it actually saves quite a bit of processing time, because especially when you're looking at some people that are newer to software development, there's this almost a default pattern that you see where they want the data to go full cycle. Like, I want to be able to query my data, and I want to show that data on the UI. Then I'm going to send that entire set of data back to an update, and then I want all of that data back, so that I just have to refresh based on that, all in kind of one big loop. But that loop creates so many points of failure that this is saying, no, 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 no. Let's get the data. That's one problem. Let's update the data. That's a different problem. If you need to request the data, you still have that original request that you can use. Does that answer your question?
And so on the GUID creation, are you saying then that you might generate the GUID in the controller level or something, and so you could actually return that immediately and also pass that down so that becomes the GUID in the table? Or are you saying that you would actually let SQL Server generate the GUID and get that back up?
I'd say that
Or it comes from the client.
The client.
Arguably, it can come as far as from the client.
Yeah.
Now, if you don't want that to be a client concern, I think the controller is a good secondary option.
Yeah.
That way that you can handle the, hey, that didn't create successfully, and not return it, and then that ID doesn't ever really live anywhere. And those types of things. But yeah, no, I in general just say so actually what I do is I say, all right, SQL Server, you can generate it if I don't give you one, but most of the cases I'm probably going to give you one. So it doesn't add unnecessary work, but yeah. Cool. All right. So that's commands. We're going to talk about queries. Now, luckily, queries are much simpler. They have a very similar structure. And so I'm not going to talk again about the domain or data access, because that really doesn't change between the two. You're interacting with the same domain, same data access that you were for the command side. The request receiver is similar in the sense that it is probably a controller or something simple. But the important difference between this one and the other one is they need to be two separate controllers. Now, the primary reason for that is that the domain repository that you're going to use here, which you can use directly in the controller, I do not care, is going to be a read-only one. So you can set up your database connection string to literally say, do not allow edits to happen. What you're basically saying is, I'm making it impossible for you to accidentally update this database on a query. And so at this point, all you really need to set up is you say, okay, I've got my read-only data access. My entire responsibility is very similar to that of events, but it's a little bit more condensed. I'm going to make sure the request is valid. The filters that I need are there. The data that I need are there. The user's allowed to call that thing, call that query or call that endpoint at all. And I'm going to map back out to whatever view that the UI needs. And this allows you to save a lot of JavaScript mapping, in my opinion. So similar controller, you've got a read-only domain repository, and you have this concept of being able to pass in, similar to having an event type, you have objects that are queries. And so and instead of having a repository pattern where you get, okay, I basically have a repository per aggregate root, and you just have a repository per domain context, right? Which could be your entire database for all I care. And so you say .query, you pass in that query object, it gives you back the ticket. In this particular example, it is just querying a ticket. And you map that to whatever you want to map that to, and you pass that view of the world back out to the UI. Now, I'm going to talk about what those queries look like, and then I'm going to talk about a little bit more into implementation. So in the queries, they are pretty straightforward, and this is basically how they can be set up, and it's not a lot of code, right? You have this read-only domain repository where all it says is query of type U, where it is an iQuery returning type U, right? And you just call execute query on it. And what that does is it allows you to do a delayed execution on a query, and you set up what that query is going to look like inside the query class. Now, the golden thing that happens here is that you can protect data on your entity based on using interface segregation on what you return out of your query, right? So in this particular example, I'm returning the full ticket object, which has all of the data that ticket could possibly have. But if I had a ticket view that was specifically for purchase that only had the cost and a couple of location and a couple of other pieces of information, no existing owner information, no pre-use owner information, none of that, I could create a interface that only has a subset of the data and none of the commands on it. I query it and I return that interface. I am essentially protecting the controller from ever touching that information if I don't want them to. Right? I could also do filters based on permissions. I could do a whole bunch of stuff. Now, if you haven't had a lot of time to tinker into some of the cool stuff that Entity Framework can do, like for example, you can add, wow, I'm blanking on the term. I want to say injector, but it's not an injector. It's like something that comes in between two other things. It is an interceptor where it takes the query and says, hey, I always want to query or filter any class has a tenant ID on it, for example, by the tenant ID of the current session. Right? I can add that and I never have to query my object. It's always queried across the board. And so Entity Framework can handle that. You don't even have to know that logic exists. But then on this level, there's still that aspect of, okay, well, this ticket is only available for people in these specific business units, or I don't know. I'm running out of examples here. And then you could do that data filter. You can do the interface. You can protect your information like that. You could do something similar like that all the way back here. Because I don't know if you noticed, but I also used the same query structure here. Now, this query structure can protect what actions I can do based on what I just queried, right? If I query for purchase, it's only going to give me the actions available for purchase based on the interface that I get back from that domain. And so you don't have to do as much protection around, hey, how did you get into this action in the domain? Are you allowed to be doing this thing becomes less of a question because you've already protected it. All right, so you get down here, you're doing a query. The query maps out, you get the tickets, you map that back out to whatever view version of that you need for the relative UI, and you return that, and you're pretty much done with query. Questions?
No questions in the chat, though. If anyone has one, please put them in.
If you have to deal with auditing of viewed data, would that be after you receive the data, then you create a command to write the audit?
Yes, however, that might actually be something that you could do on the interceptor layer where Entity Framework says, hey, every time that you query this information, kick off this event. That is something you can even do on that level and abstract that away. But yeah, that's exactly how to think about it though, of if I need something to happen as a result of something else, that is always pretty much an event that is going to be handled through the system.
Okay, but my question is, if the audit is a separate event, what happens if the audit recording fails?
So that's a good question. There are different ways to handle stuff like that. So as long as you're still inside of the same thread, right? Like you haven't exited the query thread and you make sure that you handle it that way. You can always make sure that if there's any failure inside of that, that there's an entire rollback. Like you don't let them create the action unless you can query it and do the audit on it. I don't know of I can't think of an example off the top of my head where you would actually want to stop the query unless you have an audit outside of like, I don't know, bank situations or maybe loans. I could say that, I suppose. Is that what you're referring to?
Healthcare.
Healthcare. Yeah, then that makes sense. So yeah, it would be one of those things where you wanna say, all right, they want to view this information. You might even want to do the event first, and on success of the event, you're like, cool, that didn't fail. Now I'll go query the data if it's something that absolutely needs to happen in order for the data to actually be viewed. And that may be part of the permissions check as well. Hey, does audit record exist? Question though. Do you guys work in healthcare right now?
I do.
Yeah.
Emergency room software.
Oof. That's a high risk software.
Yeah.
Do you find that there's a lot of, out of pure curiosity, is there a lot of like, what does the testing look like for that system?
There are so many variabilities and options that we have some automation testing, but then a lot of manual testing by clinical analysts who have domain knowledge.
Yeah. There's just repetition at that point. That's crazy. I would love to see that system. Healthcare's been one of the areas, like I've done a little bit in the, like, I built a retirement home management application that included caretake where we had to be HIPAA compliant and all that, but I haven't done anything in actual full-on healthcare.
I would say if hospitals were not forced to be new technology, they would still be pen and paper.
Yeah, I know, right? I mean, it's a good thing and a bad thing. Technology going wrong in a hospital could be the worst thing possible in my mind.
Yeah.
Cool. Well, that's pretty much what I had for this talk. I know that was a lot of kind of dumped information, and not a lot of time to process it. I would be happy to share this slide deck for anybody who's interested in diving deeper or continuing the conversation. But if you want that, just feel free to reach out to me. My email is robyn.fuentes@improving.com, and I can put that in the chat. So feel free to reach out, and I'll send you the deck, or if you have any other questions you want to dive in deeper and talk about what you guys are working on. I've been working on a system recently that is a full monolith system that is the standard spaghetti code. This was done in a rush type system, and we've been incrementally turning that from that system into a CQRS model and creating domains and pushing that model. And how you can take those incremental steps is a completely different conversation, but maybe a valuable one. Because we all know that as much as it's nice to talk about pretty patterns and pretty processes, we live in a real world where the software we're walking into is the software we're walking into, right?
So a question about learning more. If somebody wants to learn more about CQRS, do you have a go-to resource for that, or domain-driven design?
Interestingly enough, the way that I got into CQRS is I was presented with a small library called Highway Data. You can find it if you Google Highway Data Entity Framework. And it wraps Entity Framework to be able to set up these queries and set up commands and a couple of other things to effectively set up for CQRS. And so what I did is I took a very standard example like that and built upon it and figured out where all those edges were. And that's how I got into it, because I fundamentally believe that, like, you talk about CQRS in particular and domain-driven design, and they sound wonderful. And I know I spent a lot of time looking at that and looking at how to apply it to the code bases I was working and being like, that's cute, but it doesn't work here. And that concept wasn't broken down until I built up a sample product. I figured out where the edges were. I figured out how to make them work. And then I went, oh, this is how you apply them. And that really didn't come from any existing book or resource or anything. It came from calling different people who I knew had expertise in the area and trial and error, unfortunately. I wish there was a golden bullet, but I don't think there is one.
Anybody else have questions, comments, thoughts? Okay. Any last thoughts, Rob?
I think that's it. I've definitely enjoyed hanging out with you guys. As I mentioned, do reach out if you have comments or questions, but I hope you found it beneficial in some way, shape, or form, and that you try it out sometime.
Thanks everybody for coming. If you have any questions, thoughts, anything, you can email the officers of the group at officers@northdallas.net. So give us any feedback you want to give us that way, or you can hit us up on Slack. So we do have a Slack channel. We have that up on the website, and so you can give us feedback or talk to us about anything through email or Slack. All that works.